everyone. Uh, Welcome back to our conference. Today we have like our final day of the conference. Uh, the general agenda you can see right on the screen right now. So today we have like half day of the conference. Uh, we have a recording for the past 2 days of the plenary speaks and the short talks that you can find on our webpage. I will give a brief overview of all the talks, and then you can decide what you want to see, and then you can go to the website and watch it. Yeah, we have like a audience from the different countries, from the different time zones. So yeah, if you couldn't see some part of the conference, just please feel free to uh, go and watch from the recordings. Uh, yeah, I'm giving the brief overview of what we have learned like in past 2 days. Of course, embodied intelligence like starts with the body and environment, and one of the biggest contribution in this area is done by Professor Cecilia Lasky. Particularly in this conference, she was talking about modeling, that embodied intelligence should be modeled in considering the environment as well, like should be having intrinsic model and extrinsic model. For example, she was giving an example of the fish. The fish behaves differently in the water and in the land. So the environment is like very important to study the body as well. Uh, this example was further discussed by Neil Shubin from the evolution point of view. Neil was giving example how the fish was going out from the water to the land, starting like walking and going back uh, to the water again. He was showing that evolution doesn't really happen with the reinvention of the elements of the body, but going through the process of repurposing and duplication. And even the modern human doesn't have like much more differences from the other animals because of this repurposing and duplication. Uh, like Sylvester was uh, exploring another way of uh, seeing this problem through hard embodiment and soft embodiment. So he says that the human can repurpose a sensory motor system as well. So if we put the artificial limbs for the amputees, for example, and we can reuse the nervous system, or we can even put external other limbs like an additional hand or additional arm, for example, and then we can use the already existing like sensory motor system and feel the external hand as well. The evolution approach in the robotics was discussed by David Howard. He was showing the way of designing new robots and then benchmarking those robots against the rigid like field robotics engineered robots. Um, Jun Shintaki showed that the biomimetic robots can be really efficient and can show the performance of the real animals. He did this um, discussion on the in comparison with the real fish and the fish he designed in the lab with the properties of the real one. We also talk about the different level of intelligence, coming from all the way from the material to the mechanical engineering. The material engineering was discussed by Sylvia. Sylvia was designing various types of materials. She was talking about the self-organization of the cellulose chain, as well as like a microparticle, like which are changing the color based on the external stimuli, which can be used for the multiple purposes like sensing and so on. Then the microstructures was discussed by Amy Han. She was explaining the gecko adhesion is like a tiny structures that utilizes like van der Waals forces when when getting attached to the surface. Basically, it increases like friction a lot. And then the more like bigger structures, like programmer structures, was discussed by Andres. He was using uh, morphology to program certain behavior and use those behavior for the computation. Perla Molino, she was discussing how she can do like a logical gates using like biostable valves. Biostable valves have a special structure, and you can use them as a logical element. So your complete structure for the soft robots can be like really, really compact. And she was showing it with the example of the robotic hand, where all the valve circuits was packed within the palm. Um, Shuhei was speaking on the other end of the intelligence of the self-assembling robots. When the multiple robots can get assembled and comprise the intelligent structure, and then this like structure can show some interesting emerging behaviors that can do certain job under certain condition. Particularly, he was doing actuation with the with external magnetic fields, so the robot can move or even fly or fly off. So the magnetic power was also used by Brett Nelson. He was controlling micro robots with the magnetic power, and uh, he did a lot of work for the uh, medical purposes. He can insert like a catheter and then move all the way through the veins directly to the brain and solve uh, some brain clutter damages. Uh, uh, the similar approach using the magnetically powered micro robots was explored by Mariana. She was making a sort of a biohybrid robot where this micro robot was carrying a sperm to deliver directly to the egg. Um, Thomas was using um, soft robots to stabilize the places for the surgery. Like we all know that the heart is like very dynamic, and it basically have introduced a lot of noise, and it's difficult to make any surgery on it. So the soft robot can be used to stabilize the area of the surgery. Um, Hui-chan was exploring the adaptive nature of the soft robots. She was also using the robot to explore the pipe, and the pipe can have a different curvature at certain points. So the adaptive nature of the soft robot that she was using was helping to be adaptive and then go through the very complicated paths inside the pipe. Uh, Amy, she went a bit further. She did a catheter, like bio-inspired catheter, that was able to reduce the friction between catheter itself and the uh, and the pipe. So she was using like ultrasound vibrations that can modulate the friction between moving moving catheter and the surface. Um, Takao, he was working on the conformal electronics and the electronic skins. So he showed the approach that he used in the lab to print the electronic circuits on the stretchable surfaces, including the human skin. We talk a bit about the like embodied AI and the simulation and the lack of the embodiment or the level of embodiment in the current embodied AI works. So one of the theoretical ways of thinking was presented by Carlos. He was revisiting limits of formal system and questioning about the meaning of the general artificial general intelligence. Um, and like Yuki, she she proven in her simulation that proprioception enhances learning. So without proprioception, it's difficult to do robotic learning. But if you have some proprioception information, if you have a body, so this learning is like sped up quite significantly. Jonathan, he actually showed that the um, good physical body actually can simplify the problem of sim to real gap. So if your physical body forgives some imperfection of your simulation, you can train on simulation and use these things in the real world because of good physical body of the robot. Rika Antonova showed that realistic simulation can be done like through the differential physics. So differential physics basically can learn from the reality more closer. Um, and also both like Rika and Jonathan was discussing a lot about the current like hardware problems, which are more relates to the manipulation. We don't have a good hardware for the manipulation, and the good hardware for manipulation from the point of view of Shan is in the tactile feedback. So tactile feedback is key in the manipulation, and he's working towards the good manipulation hardware. And Matei, he did like a really great overview about the uh, level of embodiment in current embodied AI, about the sort of a lack of interaction. So the current embodied AI doesn't really consider interactive, but pre-recorded interaction. And he also emphasized that uh, embodied AI community is focusing more on the generalization across the robots, but not utilizing the robots' morphology to enhance the sensing and explore more efficient actuations, manipulations. We talk about a bit about embodied social intelligence and cognition. Rusian, she introduced this her work in human-robot interaction, particularly in non-verbal communication, which is like around 70% of all the communication among humans happens non-verbally. And Telina, he was focusing more on the facial expression for the nonverbal communication as well as the physical contact. He gave some examples of the modeling of the facial expressions, making a robotic face, as well as the using this physical contact in the robot patient scenario. Role of conversation was highlighted by Mihoko. She was saying that the conversation can reflect the mind, the way human think, and the conversations can be actually used for diagnosing some like a mental disorders. The complex social information was reviewed by Joff. He was explaining additionally like neurocomplexity, like the size of the brain, how the size of the brain is actually uh, evolved. Like, does it matter if we have bigger brain or simple brain? This all was discussed by Joff in the context of the social and the complex social information. Sheila was uh, discussing about the modeling of the embodied cognition and made a general overview of the embodied intelligence from the perspective of the embodied cognition. So this all speakers from yesterday, you can find the videos online. Please have a look. It was like really great 2 days of the conference. Um, yeah, and today we will have like a half-day conference. We will start with our first speaker, Charles Spence. Yeah, it is my great pleasure to introduce him because we all know and he's a big fan of your recent study on the gastrophysics that Fumi has just mentioned before. Yeah, and Professor Chas, he is working a lot on multisensory uh, experience of the daily life. Uh, yeah, of our daily lives. Yeah, please, Charles, if you can share your screen, the floor is yours. Yeah.
Okay. Well, thank you.